Connecting two 100 amp panels, one for a house and one for a garage, to a meter pedestal with a 200 amp underground feed requires careful consideration to avoid creating a parallel circuit which can overload the system. Connecting the two panels directly to the lugs in the meter pedestal is not recommended due to the potential for overloading the 200 amp service and creating a safety hazard. There are two main options to consider: firstly, using a special pedestal, or secondly, running two separate feeds. A special pedestal has two separate compartments, each equipped with its own set of lugs. This allows for independent connections for the house and garage to the underground feed. The pedestal must be rated for 200 amps and designed to accommodate two separate meters if required by local regulations. The alternative is to install two separate conduit runs from the meter pedestal, one to the house and one to the garage. Each panel connects to its own dedicated 100 amp feed from the meter pedestal. This approach provides independent protection for each panel and reduces the risk of creating a parallel circuit. Regardless of the chosen method, it is essential to install a 100 amp breaker in both the house and garage panels. These breakers protect the wiring and appliances in each location from overcurrents and short circuits. The recommended approach for powering a house and garage from a single meter pedestal is to use two separate feeds. This configuration ensures safety and compliance with electrical codes, providing independent protection and reducing the risk of parallel circuits. Additionally, the distance between the meter pedestal and the garage, which is 100 feet, needs consideration. Longer distances may require larger conduit and wire sizes to maintain voltage drop within acceptable limits, typically 3% for branch circuits and 5% for feeders. Factors influencing voltage drop include the wire gauge, the amount of current flowing through the wire, the type of wire, and the operating temperature. To ensure compliance with electrical codes and safety standards, consulting with a qualified electrician is crucial. They can assess the specific site conditions, calculate the appropriate wire sizes, select the correct protective devices, and ensure the system is installed according to local regulations. Prior to beginning any electrical work, obtaining the necessary permits from local authorities is important. This ensures that the installation meets the required safety standards and building codes. When working with electrical systems, safety precautions are paramount. Always de-energize circuits before working on them. Use appropriate personal protective equipment such as gloves and eye protection, and follow safe work practices. Understanding the National Electrical Code, or NEC, is essential for safe and compliant electrical installations. The NEC provides guidelines for wiring methods, overcurrent protection, grounding, and other aspects of electrical systems. Refer to the NEC for specific requirements related to meter pedestals, service entrances, and panel board installations. When calculating wire sizes for the feeders to the house and garage, consider the ampacity requirements based on the load calculations. The ampacity of the wire must be sufficient to carry the expected load without overheating. Refer to NEC Table 310.15. The 16 for ampacity ratings of various wire sizes and insulation types. The grounding system for the meter pedestal, house, and garage must be properly installed to provide a path for fault current to return to the source, tripping the overcurrent protection device and preventing electrical shock hazards. Grounding electrodes, grounding conductors, and bonding connections must comply with NEC requirements. Surge protection devices, or SPDs, can protect sensitive electronic equipment from voltage surges caused by lightning or other electrical disturbances. Consider installing SPD at the meter pedestal, house panel, and garage panel to protect valuable appliances and electronics. Proper labeling of electrical panels and circuits is essential for safety and troubleshooting. Clearly label each breaker and circuit to indicate the area or appliance it serves. Use a permanent marker or label maker to create durable and easy-to-read labels. Regular inspections of the electrical system can help identify potential problems before they become major issues. Check for loose connections, damaged wiring, and signs of overheating. Consult with a qualified electrician to perform periodic inspections and maintenance. When selecting electrical equipment, choose products that are listed and labeled by recognized testing laboratories such as Underwriters Laboratories, or UL, or Electrical Testing Laboratories, or ETL. These listings indicate that the equipment has been tested and meets safety standards. If the meter pedestal is located in an area subject to flooding or moisture, take precautions to protect the electrical equipment from water damage. Install the pedestal on a raised platform or use waterproof enclosures to prevent water from entering the electrical components. Consider using ground fault circuit interrupters, or GFCIs, in areas where there is a risk of electric shock, such as bathrooms, kitchens, and outdoor locations. GFCIs detect small imbalances in current and quickly trip the circuit, preventing electrical shock. When installing conduit for underground wiring, ensure it is buried at the proper depth to protect it from physical damage. Refer to the NEC for minimum burial depth requirements based on the type of conduit and the location. Use appropriate fittings and connectors for all electrical connections to ensure a secure and reliable connection. Avoid using substandard or unapproved fittings, as they can lead to loose connections and electrical hazards. When working with aluminum conductors, use connectors and fittings that are specifically designed for use with aluminum. Aluminum and copper can corrode when they come into contact with each other, so it is important to use compatible materials. When pulling wires through conduit, use a wire pulling lubricant to reduce friction and make the job easier. Avoid using excessive force, as this can damage the wires or the conduit. Consider using a cable management system to organize and support the wiring inside the electrical panels. This can help prevent tangled wires and make it easier to troubleshoot and maintain the system. Use appropriate strain relief connectors to prevent the wires from being pulled out of the electrical boxes or equipment. Strain relief connectors provide a secure connection and prevent stress on the wires. When making connections to electrical terminals, ensure the wires are properly stripped and terminated. Use the correct size and type of wire connectors and tighten them to the proper torque. Always follow the manufacturer's instructions when installing electrical equipment. This ensures that the equipment is installed correctly and will function properly. If you are not comfortable working with electrical systems, it is always best to hire a qualified electrician. Electrical work can be dangerous, and it is important to have the knowledge and skills to do the job safely. Consider the long-term maintenance requirements of the electrical system. Regular inspections and maintenance can help prevent problems and extend the life of the system. Keep accurate records of the electrical system, including wiring diagrams, load calculations, and inspection reports. This information can be helpful for troubleshooting and future upgrades. When making changes to the electrical system, be sure to update the records to reflect the changes. This will help ensure that the records are accurate and up to date. If you are planning to add more electrical load to the system in the future, be sure to factor this into the design. This will help ensure that the system is adequate to handle the increased load. Consider using energy-efficient appliances and lighting to reduce the overall electrical load. This can save money on energy bills and reduce the strain on the electrical system. Be aware of the potential hazards associated with electrical systems, such as electric shock, fire, and explosions. Take precautions to avoid these hazards and follow safe work practices. Educate yourself about electrical safety and be aware of the potential risks. This will help you to stay safe when working with electrical systems. If you have any questions or concerns about electrical safety, consult with a qualified electrician. They can provide you with the information and guidance you need to stay safe. The information provided here is for general guidance only and should not be considered a substitute for professional advice. Always consult with a qualified electrician for specific recommendations related to your situation. The electrician will be able to assess your specific needs, design a safe and compliant electrical system, and ensure that it is installed properly. Remember to always prioritize safety when working with electrical systems. Electricity can be dangerous, and it is important to take precautions to avoid electrical shock and other hazards. By following these guidelines, you can help ensure that your electrical system is safe, reliable, and compliant with electrical codes. And remember, Always consult with a qualified electrician for any electrical work that you are not comfortable doing yourself. They have the knowledge and experience to do the job safely and correctly. Before commencing any electrical work, it is crucial to conduct a thorough load calculation for both the house and the garage. This calculation will determine the total electrical demand of each structure, including lighting, appliances, and other equipment. The load calculation will help determine the appropriate size of the service entrance, panel boards, and branch circuits. Refer to NEC Article 220 for guidelines on load calculations. After determining the total load, select the appropriate size conductors for the feeders to the house and the garage. The conductors must have an ampacity rating sufficient to carry the calculated load, taking into account any applicable directing factors for ambient temperature or conduit fill. Refer to NEC Table 310.15. B16 for ampacity ratings of various conductor sizes. When selecting overcurrent protection devices, such as circuit breakers or fuses, choose devices with an interrupting rating sufficient to handle the available fault current at the service entrance. The interrupting rating is the maximum amount of current that the device can safely interrupt without failing. Consult with the local utility company to determine the available fault current at the service entrance. Ensure that the grounding system is properly installed and connected to a grounding electrode system that meets the requirements of NEC Article 250. The grounding electrode system must consist of a grounding electrode conductor connected to a grounding electrode, such as a ground rod, ground plate, or metal water pipe. All metallic components of the electrical system, including conduit, enclosures, and equipment, must be properly bonded together to create a low impedance path for fault current to return to the source. Bonding jumpers must be sized according to NEC Table 250.102. When installing conduit, use appropriate fittings and connectors to ensure a watertight and secure connection. Seal the ends of the conduit to prevent moisture from entering the system. Support the conduit properly to prevent sagging or damage. When pulling conductors through conduit, use a wire pulling lubricant to reduce friction and make the job easier. Avoid pulling multiple conductors at the same time, as this can damage the conductors or the conduit. When making connections to electrical equipment, ensure that the conductors are properly stripped and terminated. Use appropriate wire connectors and tighten them to the proper torque. Follow the manufacturer's instructions for making connections to the equipment. After completing the electrical installation, conduct a thorough inspection to ensure that all work has been done properly and that the system is safe and compliant with electrical codes. Check for loose connections, damaged wiring, and other potential hazards. Test all circuits to verify that they are properly wired and that the overcurrent protection devices are functioning correctly. Document the electrical installation, including wiring diagrams, load calculations, and inspection reports. This documentation will be helpful for future maintenance and troubleshooting. Keep the electrical system clean and free of debris. Dust, dirt, and other contaminants can cause electrical equipment to overheat and fail. Schedule regular maintenance inspections to identify and correct any potential problems before they become major issues. Regular maintenance can extend the life of the electrical system and prevent costly repairs. Consider installing a whole house surge protector to protect sensitive electronic equipment from voltage surges caused by lightning or other electrical disturbances. A whole house surge protector can help prevent damage to computers, televisions, and other valuable appliances. Be aware of the potential hazards associated with electrical systems, such as electric shock, fire, and explosions. Take precautions to avoid these hazards and follow safe work practices. If you are not comfortable working with electrical systems, it is always best to hire a qualified electrician. Electrical work can be dangerous, and it is important to have the knowledge and skills to do the job safely.